So I'm making one more video about an example problem from 7b. In this problem, we want to determine whether the following individual events are independent or dependent. Then we want to find the probability of the combined event. The probability here, the event that we're looking at, would be drawing 3 face cards. So remember, face cards would include your jack, queen, and kings. Drawing 3 face cards in a row from a standard deck of cards when the drawn card is not returned to the deck each time. We call that without replacement. So we are drawing a card, and it can be, we want to find the probability of a face card, so we'll talk about how many there are. Then we're drawing a second card to find the probability of drawing another face card, and third. Because each sequential draw relies on the previous one, these are dependent events. This is an and problem, drawing 3 face cards. So I want to draw a face card and a face card and a face card. This is an and problem, and these are dependent. So each probability that I multiply, we will be multiplying. Each probability that I multiply, I need to think about what happened to the previous one. We'll first go through the events here, and we'll go through each different probability. So for the first draw, there are 52 cards in the original deck, and there are 12 face cards. 12 out of 52, if you divide 12 by 4 and 52 by 4, you get 3 over 13. 4 over 4 cancels to give us 1. So there are 52 cards in the deck. 12 of those are face cards from the initial deck. The probability of drawing a face card from the first card from off of a fresh deck, the probability of drawing a face card would be 3 out of 13. Now, instead of multiplying that times itself 3 times, I have to keep in mind that these are dependent events. If they were independent, I would just multiply 3 over 13 times itself 3 times. But I can't do that here because this is without replacement, so the second draw depends on the first one. Now there are only 11 face cards left in the deck, and there are only 51 cards left in the deck. So the probability of drawing a face card after you've already drawn a face card would be 11 out of 51. So notice that that was conditional. So dependent cases, you must think about what happened before. For the third draw, there are now only 10 face cards in the deck out of 50 cards. We've taken 2 from the deck, so now there are only 50 cards. 10 over 50, by the way, is 1/5. 11 over 51 doesn't simplify. So you'll notice I'm simplifying my fractions each time because it makes my work a little bit easier. I may still need to simplify in the end, but simplifying as you go helps take a little bit of work, alleviate a little bit of work when you're trying to simplify your final answer. The final answer here, I'm going to multiply each of those different probabilities. So 3 over 13 times 11 over 51 times 1/5. Multiply across the numerator. 3 times 11 times 1 is 33. 13 times 51 times 5, you'll look for that product. There's something you'll notice here, so especially since I'm typing this up. 3 times 11 times 1 is 33, and you'll notice I said that. But 51 is divisible by 3, so I simplified that. So since there was a 3 in the numerator and a 3 as a factor in the denominator, 3 over 3 cancels. 51 divided by 3 is 17, so that's why I have a 17 here. So this term here is actually, it's completely equivalent to the product I have initially, but it's simplifying. So I'm simplifying as I go. It takes away some, it eliminates some work in the end. You'll notice since I simplified as I went, I have my final answer. 11 is prime. It will not go into 1,105. So this would be my final answer. In the MyLab Math, you'll be able to type in the fraction form. So I'll simply type in 11 over 1,105. So this was an example straight from your homework, one of the last problems in 7b.